Well, happy Tuesday, everyone. A big shout out to Laura. Hope you're having a great day. Alright, so today we are going to discuss, or I'm going to talk about the beginnings, the probability, the beginning stuff, the fundamental accounting principles. We're going to talk about permutations. We're going to start with a tree diagram. So stop the slide right now and create a tree diagram showing the possible sandwich combinations for meats and breads. You have 4 kinds of meats and you have 3 kinds of bread. Please right now stop and do that. Alright, welcome back from having created your tree diagram. Your tree diagram should look something like mine. Now, if you notice, on the left I have the ham, the turkey, the roast beef, and the pastrami, and off of those I have the 3 bread choices. So in other words, I have ham on white, ham on wheat, ham on rye, turkey on white, turkey on wheat, turkey on rye, roast beef on white, roast beef on wheat, roast beef on rye, pastrami on white, pastrami on wheat, and pastrami on rye. I did that all in one breath, by the way, if you didn't notice. Those are your answers. So how many different kinds of sandwiches could you get? Well, 12 different sandwiches could be made based off 4 meat choices and 3 breads. So what does that lead me to? It leads me to the fundamental counting principle, which states that if you have 2 events, if one event can occur m number of times, in other words, the meats was 4, and another event can occur n ways, bread was 3, then the number of ways that both events can occur is m times n. Or in other words, for our tree diagram, 4 meats times 3 breads is 12 different possible sandwiches. 3 events. It's going to be the same thing, except now you're going to multiply 3 things together. So now let's say that I had 4 meats times my 3 breads times, let's say I had 5 different cheeses. Well, what is that going to be? Well, that's going to be 60 different sandwiches I could make, right? All right, so you're just going to keep adding them together. It's on the printer. Sorry for that delay. Someone came in to get something off the printer. Okay, so now let's move on. Here's some examples. And technically, if I were here today, I'd make one of you come to the board and do one of these. So you are choosing a password that has 4 letters followed by 2 digits. So part A is asking you how many passwords are possible if letters and digits can be repeated. That's the key part here, can be repeated. So I'm looking at a passcode which has 6 different things. 1, 2, 3, 4, 5, 6. I know that I have to have 4 letters, so letter, 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 letter. This will be a number, and this will be a number, or a digit. Well, how many letters are in the alphabet? That's right, there are 26 letters in the alphabet, so it's going to be 26 times 26 times 26 times 26. How many different digits are there? And this is where you're all going to get confused. There are 10 digits. So this is times 10 and times 10. Those 10 digits start at 0. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are your digits. So you're going to take 26 times 26 times 26 times 26, and you will get, when you do that, a whopping 45 million. So the answer here is right here, 45,697,600 different combinations. Now the next part says, okay, same deal, letter, 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 number, number, but this time you cannot repeat a letter. So when I first start out, I have 26 letters in the alphabet I can choose, but I just used one of them. So now I have 25 possible letters. And then I've used another one, so now I have 24 possible letters. And I've used another one, so now I have 23. When I start with my digits, I start out with 10 digits, but after I use one of them, I only have 9. When you multiply all of that together, you get 32,292,000 different combinations. So that's, and when I say combinations, I mean you've got 32,292,000 different passwords you could possibly have. So instead of saying different combinations, you could have written 32,292,000 passwords, possible passwords. Okay? Let's talk about permutations. An ordering of a set of objects is a permutation of the objects. By the fundamental counting principle, there are 3 times 2 times 1 equals 6 permutations of 3 objects. In other words, I have the letters A, B, and C, which is 3 letters. How many different ways can I order that? Well, I can order those 3 different letters 6 different ways, and you can see that I've done that for you. So the expression 3 times 2 times 1 can also be written as 3 factorial. The symbol, which is the exclamation mark right here, the symbol is the factorial symbol and is read 3 factorial. In general, the number of permutations of n distinct is n factorial. What does that mean? Well, in fancy language, n factorial equals n times whatever n minus 1 is, times whatever n minus 2 is, and you keep doing that so on and so forth until you get to the number 1. So we're going to look at some examples here on the next slide. So if I tell you that I have 4 objects, that means I have 4 factorial, which is the same thing as 4 times 3 times 2 times 1, or that equals 24. 5 factorial is 5 times 4 times 3 times 2 times 1, and that equals, when you multiply this together, 120. 6 objects, or 6 factorial, is 6 times 5 times 4 times 3 times 2 times 1, and that is 720. What does 10 objects look like? Once again, this would be your turn, and I would have you come up here. So take a moment. What do you think 10 objects would look like? That's right, it would be 10 factorial. And how do you write that out? That's right, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you put all that into your calculator, you get 3,628,800. So now what's important about knowing factorials is now I know what they are, I now need to use them in the formula for permutations. But we're not there yet, so it's coming. Bear with it, because if you noticed, we're only on 7 of 13 slides right now. So 8 skiers are competing in moguls. Moguls are the snow bumps when you're talking about the Olympics. In how many different orders can 8 skiers finish the competition? Well, order doesn't matter. I don't care what order they're coming in. So 8 factorial, so that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which equals, and you're going to put that in your calculator, and you're going to come up with a number. What number do you come up with? You come up with 40,320 different ways in which they can come in. Okay, right? Now, what about how many different ways can three of our skiers finish first through third place? In other words, when I start this, I have eight skiers who are competing for the gold. But once somebody wins the gold, now I only have 7 going for the silver, right? And then I have 6 going for the bronze. Think of it that way. So that's 8 times 7 times 6, or there are 336 different ways, the skiers can come in to the finish line in order to get first, second, and third place. So next slide, of course, is your turn. So take a moment. I'll read it to you, and you can read it to yourself, and then try to work these out. A television news director has 7 news stories to present on the evening news. How many different ways can the stories be presented? So how many different ways can I present those 7 stories? How would I write that? You're right, that's 7 factorial. So that's 7 times 6 times 5 times 4 times 3 times 2 times 1. And when I take and put that in my calculator and multiply that all out, there are 479,001,000 600 different ways I can order those 7 stories. If only 3 of those stories will be presented, so I'm only going to do 3 of them. Of those 7, I only want to do 3. How many possible ways can a lead story, a second story, and a closing story be presented? Well, just like on our last slide, that's going to be 7. There are 7 possible ways for me to do that very first story. 7 possible stories to pick from. Once I've picked one story, now I only have 6 stories to pick from. And then once I've picked that story, I only have 5 more to pick from. So when we multiply that, there are 1,320 different ways I can order those 7 stories for those 7 news stories for the first 3 spots. All right. Now, here's the formula for the day. This is a permutation of n objects taken r at a time. That is denoted by n, that's your number, r is your rate. So this is the bigger number is here, smaller number is here. And this is the formula. So in other words, you have 6 text messages on your cell phone. In how many orders can you reply to 4 of the messages? And then the second part of the question is to 6 of them. So if I only have time to respond to 4 of those 6 messages, this is what it would look like. 6p4, which means I'm going to have 6 factorial over 6 minus 4 factorial, which means I have 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, because 6 minus 4 is 2. And so 2 factorial is 2 times 1. Well, let's do some quick help here. This and this cancel, so all I'm multiplying together is 6 times 5 times 4 times 3. And when I do that, I get 360 ways in which I can order the 4 of those 6 texts that I decide to do. Now 6p6 means I'm going to have 6 factorial, because that's the number out here in front first, and then I'm going to take 6 minus, this time 6 factorial. So what's that going to look like for me? Well, that's going to look like 6 times 5 times 4 times 3 times 2 times 1 yet again. But 6 minus 6 is 0 factorial. By the way, 0 factorial equals 1, the number 1. So it's not like I'm dividing by 0. So when I take all that and I multiply it out, I get 720 different ways in which I can order these 6 text messages. You guys go ahead and say that fast several times. 6 text messages that I can put them in order. So you're at the you're grocery shopping. You have a grocery cart full of 8 items. How many different orders, in other words, how many different ways? Do I put the tomato sauce up first, and then the celery, and then the apples? Or do I put the apples first and the celery? I mean, how many different ways can I put 5 of those items on the conveyor belt? So that would be 8p5. So what does that look like? That's 8 factorial over 8 minus 5 factorial, which is really 8 factorial over 3 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1. So when I'm doing this, I say these guys cancel, and in my calculator I'm taking 8 times 7 times 6 times 5 times 4. And when you do that, you will get 6,720 different ways, 6,720 different ways in which you can put 5 of your 8 items on the conveyor belt at the grocery store. Now we've decided we're going to put all of them up. So now that's 8 factorial over 8 minus 8 factorial. So really what I have is 8 factorial, which is really 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you put that all into your calculator, you will find out that there are 40,320 different ways that you can take the stuff out of your cart and put it onto that conveyor belt. All right. Now let's find the distinguishable permutations of n objects where 0 objects is repeated q to the 1 times. In other words, we're going to take and we're going to take words. And you're going to find on your homework tonight, you're going to have a series of words in which you have to find the permutation of the letters. How many different ways can I order those letters? So the first thing you need to do is look at the word and count up how many total letters there are. Well, in Ohio, there are 4. And then how many of those letters repeat? Well, O repeats. Make mental note of that, because how we're going to write this is like this. We're going to start with the 4 factorial. So on top we have the total number of letters. That's what's on top. And that's not 6 letters. That's letters, L-E-T-T-E-R-S, letters. So the total number of letters, 4 factorial, is on top. On the bottom, we're going to look at each letter. Does O repeat? Why, yes, it does. How many times does it repeat? 2 factorial. Times. H. How many H's do I have? I have 1, so that's 1 factorial. Times. How many I's do I have? 1, so that's 1 factorial. So when I'm writing this out, this is 4 times 3 times 2 times 1. Over 2 factorial, which is 2 times 1. 1 factorial is 1. 1 factorial is 1. They don't count, so we don't even bother. Those will cancel. So there are 12 different ways I can write the letters O-H-I-O. 12 different words I can form. Some of them are gibberish words, but there are 12 different ways. Let's look at Mississippi. So we're going to count at Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total letters. Let's start with the M. Does the M repeat? Nope, there's only one of them, 1 factorial. Times. I, does the I repeat? Yes, I see 4 of them, so that's 4 factorial. Does the S repeat? Yes, it does. I see 4 of those, so that's 4 factorial. Does the P repeat? It sure does. That's 2 factorial. So that covers all of my letters. So remember, this was the M, this was the I, this was the S, and this is the P. So that becomes 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Well, 1 factorial is 1 times 4 factorial is 4 times 3 times 2 times 1 times another 4 times 3 times 2 times 1 times a 2 times 1. So now I start canceling. So this 4, 3, 2, 1 right here, well, 4, 3, 2, 1 takes out the first 4, 3, 2, 1. This 3 and this 2 right here, that's 6. So that will take out the 6 right there. This 4 right here times that 2 right there is 8, which will take out the 8 right there. So now all that's left on the bottom is 1s, and on the top I'm going to take and I'm going to multiply 11 times 10 times 9 times 7 times 5. Those are the numbers I'm going to multiply together, and I'm going to come up with 34,650 different ways in which I can arrange the word Mississippi, the letters in the word Mississippi. So there are 34,650 different words I can come up with. Not really, if you think about it, due to the fact that the S's and the I's and the P's, you're just going to use a different one each time, so you can get the same word multiple times, but there's different ways I can do those letters. All right, we are finishing up. All right, you do not have worksheet B, you're just doing A. You're doing all of A. And be ready for a quiz on Wednesday. We're going to start the hour on Wednesday with a quiz over the material for today. So make sure that you know what you're doing. Quiz on Wednesday. Okay, I will see you all back here on Wednesday. I hopefully am enjoying my anniversary, and good luck to all of you. Behave, be good, be well.